Here we have the assignment 5-4. We're solving the system of equations using elimination. Both of these equations, it's not set up as it is to get either one of the variables to drop out. The x's are going to be the easiest to get to drop out. All I'll have to do is multiply through one of the two equations by -1, and then that'll get me in a situation where the x's will eliminate themselves. So that'll become -x plus 3y equals -7. The second equation will remain the same. X plus 2y equals 2. And I'll add the two equations together. I know the x's will be eliminated because that'll be a 0 pair. That'll give me 5y equals 5. So I don't need to write the 0 plus. That doesn't do anything. You just divide by 5, and y is 1. I'll take that and plug it back into one of the two equations. Doesn't matter which. I'll use the second equation, and I can solve for x. X plus 2 equals 2. Subtract 2 from both sides, and x is 0. So the solution to the system of equations was 0 for x and 1 for y. In problem number 2, there's two choices. I can get the x's to drop out, or I can get the y's to drop out. They're both not much different as far as work goes. I'm going to go ahead and I'm going to get the y's to cancel out. So I'm going to multiply everything by -2, and that'll make that equation -2y minus 6x equals -6. And the bottom equation will be left alone. Positive 2y plus 2x equals -2. So when I add the two equations together, my y's 0 out, and I'm left with -4x equals -8. Divided by -4, and x would be a positive 2. So to find that, I can plug it back into the equation. One of the two, I'm going to use the top one. Y plus 3 times 2 equals 3. Is y plus 6 is 3. Subtract 6 from both sides, and y would be -3. So y is -3, x is positive 2. Problem number 3, I'm going to do pretty much the same way. I'm going to get the x's to drop out, so I'm going to get I'm on a -3x from here, and I'll leave the second equation alone. 7y equals -10. So to get that, I had to multiply everything by -3. So -3 times x was a -3x. -3 times 5 is going to be a -15y. And then -3 times 4 would be a -12. So when I add the two equations together, my x terms get eliminated. I'm left with -22y equal to -22, which means y is positive 1. So when y is 1, plug that back into one of the two equations. X plus 5 times 1 equals 4. So x plus 5 is 4 minus 5 from both sides, and x is -1. So x is -1, y is 1. You can either write it that, or you can just write, make sure you put them in the right place if you're going to write it with an ordered pair. All right, number 4 is going to take, I'm going to have to modify both equations to get a variable to eliminate. So I'm going to go ahead and try to eliminate the y's since they have opposite signs. At least I'm a step ahead. So I'm going to have to multiply, so I have a 7 and a 2. And so the least common multiple of 7 and 2 is 14. So I'm going to have to multiply that one by 2. Then I'm going to multiply that one by 7, and that'll give me 14y and a negative 14y. But I'm going to have to multiply, again, like before, I'm just showing it a little bit different way. I'm going to have to multiply everything by, so that it'll grow proportionally. So that'll give me 8x minus 14y equals 20. Again, I'm doing it the same way. I'm just showing the multiplication a little bit differently. Hopefully it'll help some of you understand. 21x plus 14y equals negative 7 times 7 being negative 49. Now I'm ready to add the two equations together, and I get 29x, and the y is eliminated like I had planned it, equals to negative 29, and so x is negative 1. Plug negative 1 back into one of the two equations. Let's go with the second one. 3 times negative 1 plus 2y equals negative 7. Negative 3 plus 2y equals negative 7. Add 3 to both sides. We get 2y equals negative 4. Divide by 2 on both sides, and y would be negative 2. Y is negative 2, and x is negative 1. Number 5, we got, again, I'm going to have to do a little bit of work, and either way it's going to be, I'm going to have to modify both equations. I want to get the x's to cancel out or the y's to cancel out. I don't have any, the x terms nor the y terms have opposite signs. So one of the two equations is going to have to be multiplied by negative 1. So I'm going to multiply the top equation by, I'm going to go ahead and try to get the x's to cancel out. So I'm going to need to make, with 3 and 4, I'm going to need to get a 12x and a negative 12x. So I'm going to multiply this one by 4. So I'm going to have to multiply everything by 4 in that equation. And that'll give me 12x minus 32y equals 52. And then I'm going to get the x's to cancel out, so I'm going to need to multiply this one by a negative 3 so that I get my negative 12x, and everything gets multiplied by negative 3. So that'd be positive 15y equals a negative 18. So that took a lot of work just to get that ready to have elimination occur. My x's cancel out like I designed it. I'm left with a negative 17y equals positive, let's see, 34, I think. And divide both sides by negative 17, and y would be a negative 2. So take that and plug it back into one of the two equations. I'll use the bottom equation for x minus 5 times negative 2 is equal to 6. So 4x plus 10 would be 6. Subtract 10 from both sides, and I get 4x equal to negative 4, and then divide both sides by 4, and x would be negative 1. So I get x equals negative 1, y equals negative 2. Just for practice, we're going to, just as a review, we're going to practice the other two methods of solving systems of equations. First one we learned was graphing, second one substitution, and then the third one, what we just did, was elimination. So if we're going to do it by graphing, then we're going to have to get both of these equations, we're going to get both of these equations into slope-intercept form. so that we can graph them. So when I change these equations into slope-intercept form, I get, when I subtract x from both sides and then divide everything by -2, I get y is 1/2 x minus 1. And then the second equation, just subtract 3x from both sides and I get it in the slope-intercept form. It's -3x plus 6. So if I graph this equation first, start at -1, and it has a 1/2 slope, so up 1 over 2. All the way across the page. Use my other equation, -3x plus 6. So start at 1, 2, 3, 4, 5, 6. And do a -3 slope, down 3 over 1. There's my point of intersection. That's what I've been looking for. Down 3 over 1. 3 over 1. So there's just to finish that out. So here is my point of intersection, and that's the point 2, 0. Problem 7, we're going to use substitution. So we need to get one of the variables isolated. Let's go ahead and use that equation. If we just add y to both sides, we get x equal to y plus 4, which is pretty easy to use it for substitution. So -5, I'll substitute x plus 4 in, or y plus 4 in for x in the second equation. So it'll be -5 times y plus 4 plus 3y equals 6. Now I can solve for y. I get -5y minus 20 plus 3y equals 6. That becomes -2y when I collect my y terms together. Minus 20 equals 6. Add 20 to both sides. I get -2y equals 26. Divide both sides by -2. I get y equal to a -13. So y is -13. And I can take that and plug it back into this easy equation, or even this simple equation. If x is equal to y plus 4, so I'll say x is equal to -13 plus 4. That would mean x would be equal to -9. Okay, and this concludes 5-4.